Okay, so these are solutions to the practice paper H, paper 2. Question 1 is your straightforward repeated percentage. We have an antique going up in value by 4.5% for 3 years. So if something's going up, you start with 100, you add on 4.5, which is 104.5%. As a decimal, you divide that by 100, so your multiplier is 1.045. Oops. And we're doing that for 3 years, so power 3 times the value of the chair. And then simply make sure you type that into your calculator very carefully. And they've not mentioned any rounding here, so we just do it to nearest penny because it's money. So 684 is 699, so that would go up to 70 pence. Okay. Question 2, mean and standard deviation. Right, I need to create a wee bit more room for myself here. So the mean is when you add all your numbers up, and so standard deviation, right, I do this method. This might not be the method you like, but it's the method I always do. And I know I'd always try and show 2 methods, but with standard deviation, I'm only going to show the one. So you put all your numbers in there. I just put them in the order that they appear in. I don't bother changing them because then I might miss one out. Right, so my mean is, when I add up all these numbers, I get 49. And I had 7 numbers, so 49 over 7 is 7. So my mean is 7. The middle column is each of my numbers on the left take away 7. So that is 6, 0, minus 7, 2, 0, 1, and minus 2. And then square each of those numbers. So remember, they always turn positive. Common mistake is saying 1 times 1 is 2. Right, and then I do that. And then what I do is I get the total. So add up all these numbers. And I get 94. Now, standard deviation is sum of the x minus x squared, so it's that total all over. Now, I had 7 numbers in the list, so n minus 1, you do 7 take away 1, so it's 6. So I'm doing 94 divided by 6, and then taking the square root. And it gives me 3.96. I've not mentioned rounding, so I'll just leave it as that. So that was part A. So that was the team for the rugby scores in a series of matches. Okay, so apologies, I need to rub out a wee bit here so I can read the rest of this. So the following season, the team appoints a new coach. Similar series of matches produces a mean of 27 and a standard deviation of 3.5. Okay, so what I always like to do is I like to write a wee bit of information out before I compare it. So before, the mean was 7 and the standard deviation was 3.96. After the new coach, my mean is now 27. So you can see that's jumped, and my new standard deviation is 3.25. Make 2 comparisons about the performance of the team under the new coach. Right, so the average score, the mean has jumped. So I'm going to say the average score has improved or jumped up. Either way, so the average score has improved with the new coach. And the scores are, the standard deviation has gone lower, so that means not much lower though, but that means that the scores are a lot closer together than they were before, so the scores are now less varied. Closer together means less varied. You don't need to say why, but it is because it's a lower standard deviation. That's a perfect sentence. Turn the word mean into average. Make sure we know what we're talking about. We're talking about scores. We're talking about a new coach coming in. That's it. Okay, so we have a vector question. We're told important things are, we're told the m is a midpoint and the n is a third of the way down. So we have to find the coordinates of m and n. I'm going to make this ever so slightly bigger. Okay. So m is away over here. So remember, you go x, y, z, so follow the x, the y, and the z. So at a long number, m isn't along anything at all. It's halfway back. Now, if I look at the back number for Q, that was a back 2. So halfway of that would be 1. And then it's not up anything at all. Coordinate for N would be along as far as P, so it's along 4. It's back as far as Q, so it's back 2. Now it said that UN was a third of the way, UN was a third of U to Q. So that's like part 1, and then there's 2 parts there. So technically I'm 2/3 of the way up. Now it goes as high as 3, so 2/3 of the way up there would be 2. That's a tricky one. Question 4, find the equation of a straight line. So first thing is getting your gradient. So subtract the y's. So I've got 5 minus 4. And then subtract the x's. So I've got 2 minus 1. They're double negatives, so they turn into pluses. So it's 9/3. My gradient is just 3. I've no y-intercept, so I'm going to use the y minus b equals mx minus a formula. Pick one of your coordinates. I always use the positive one if I can. Make that your a and your b. So you've got y minus 5 equals 3, bracket x minus 2. Expand your bracket, gives you 3x minus 6. Minus 5 comes over and becomes plus 5, so minus 6 plus 5 leaves you a minus 1. So the equation of the line is that. Question 5, we have a spiral staircase. It wants to know, for safety regulations, the arc must be at least 0.9. So they're asking us to find the arc. So formula for arc, I need to just come make a wee bit of space myself. So arc equals your angle over 360. Arc is like circumference, so it's times pi d. Now my angle was 42. So 42 over 360 times pi. Now my radius was 1.2, so that makes my diameter 2.4. So typing that in, you get 0.858, so let's say 0.86. So it says for regulations, the arc must be at least 0.9. So we've not made it. So our answer says that the arc is actually less than 0.9. So it won't pass. So you have to say, will it pass, will it not pass? So I've said it won't pass. And you have to say why. And the reason is because we worked it out to be 0.86, which is less than 0.9. So I've just said it in numbers. Okay, next question is the volume of a cone with a wee cone cut off the top. So it's a bit like when you snap the bottom of your ice cream cone, that's what's happening there. So our method is big cone, take away wee cone. One thing to point out though is the height of the wee cone is a tricky bit. The full cone is 24, the main bit that's being left is 16, so 24 take away 16 is 8. So when it comes to do the little cone, I'm going to use a height of 8. Now, formula for a cone is 1/3 pi r squared h. So I need the radius for each of them. So the small cone has got a radius of 5, and the big cone has a radius of 15. So I'm going to come down and do the work in here. So for the big one, I'm going to do the small one first. So the small one, no, I'll do the big one first. Volume is 1/3 pi r squared h. So that is 1/3 times pi times a radius of 15 squared, and the height of the big one was 24. The little one will be 1/3 times pi. Remember, the radius of the little one was 5, and the height we said was 8, and that's the stumbling block in that question. So I'm going to work out the two answers now. So that's the two formulas. So the actual volume that's left over, remember, will be volume 1 take away volume 2, which leaves us with 5.43. But question said 2 sig fig. I always check at the end. Any volume or percentage question, check for sig fig. So that will be 5, 4. That won't change. So there is your formula to two significant figures. Okay, Paul's got a summer holiday. It's got a 4% booking fee. What is a holiday without a booking fee? So basically, Paul's holiday price started at 100% and they added on 4%. So the price he is now paying is equivalent of 104%. So that's what that number is. We need to get 1% and then the full price, which is 100%. So it's like a proportion question. So we divide this number by 104, which is 8.6. We then times that by 100, which is 860. So Paul was paying £860. Now you can always double check this and check that what 4% of that is. 4% of £860 is £34.40, which is exactly what's been added on. Okay, so what we have is we have a beam resting against a wall, and then they've put in a cable, and they've made this lovely diagram, and they've asked us to work out C to B, right? So this is what we're after. At first glance, I thought this was a double sine rule question, but double sine rule would normally ask you for like maybe this bit here and say the height of two buildings, but it doesn't, so it's not a double sine rule question as I first thought. First thing we have to do though is fill in all our missing angles. This one here is 121 because it's on a straight line with 59. This one up the top is going to be 31, 31. And then this one in here, using the 22 and the 121, given us 143, that's going to make that one 37. Now, I've got enough information just in this ABC triangle now to go work out what x is. I don't have two sides and an angle in between, so it's not a cosy corner, but it is sine rule. I've got an angle and a side opposite. I've got an angle and a side opposite, which is 8. So that's what I'm going to be using. So my unknown side over sine 121 is my known side of 8 over sine 22. And then from there, I can go work out the rest. So I just need to bring up the 121. So x equals 8 times sine 121, all over sine 22. And if I type that in, so 8 sine 121 gives us 18.31. And it was in metres, so the cable's 18.31 metres. They've not mentioned any kind of rounding, so that will do. Next one is mathematically similar. It's a similar shape. It tells us about area, so it's a similar area question. We have to find the area of the larger bead. So remember, for area, the area we want, so the big area, will be our scale factor squared times the small area. That's a kind of general formula. So our scale factor goes big over small, or new over old. So I've got 4 over 0.8 squared times the small one has an area of 0.6. And then you can just go do that all in one go in your calculator. And then work out your answer. There's no need to actually simplify that down. And it gives us an answer of 15. So the big one has an area of 15 square centimetres. Right, so we're told this is a rhombus, and we have to find the area of the rhombus. So this is 40 and this is 40. Right, there's two options here. I'm probably going to split it down the middle here, and I can find the area of one side and then another one. So area of a triangle is half AB sine C, right? But I've got two of them, so I'm going to double it. So really that half and the times 2 are going to counteract. So a rhombus is just AB sine C, although we don't teach that. But yeah, we do have two identical triangles, so I'm probably just going to keep going with the triangles. So I've got a half of 40 times 40 times sine 110. And then I've got two of them, so I'm going to times it by 2. You might want to do that separately and get the area of 1 first of all, and then double it at the end, but I'm just going to do it all in one go. And that gives us 1503.51 square centimetres. So it's recognising that a rhombus is just two identical triangles, and area of a sine rule for that one. Question 11, we have f of x equals 3 sine x, so we have to find f of 270. So we are just plugging in x is 270, so that is the same as 3 sine 270. and you can do that in your calculator, is -3. Can I just, at this point though, if this was non-calculator, this could be non-calculator. There's your 270 on a graph. If this was a 3 sine graph, 270 would be your lowest point. So 273 times sine 270 would have been at -3 as well. So it could have been non-calculator. Then it tells us this equals 0.6. So you put your equation equal to 0.6 and watch x is also changed to a t. So we have 3 sine t equals 0.6. Sine t is, that divided by 3 is 0.2. Now at the moment that is a positive number, so I'm going to use all in sine when I tick my boxes, not tan and cos. So your acute angle is when you do shift sine of 0.2, which gives you 11.53. I always round it to one decimal place. So t is 12 from your all box, or 180 take away 12 from your other box. So t is 12 or 168 degrees. Okay, next one is your classic tunnel tanker question. We want to find the depth of the oil. So I'm going to draw in a right angle triangle. We are told that the radius is 1.9, so your slope is 1.9. And we're told that A to B is 2.2, so this wee bit here is 1.1. So I'm going to work out that bit. So I'm going to do x squared equals 1.9 squared minus 1.1 squared. And remember, it's very important to always draw your triangle first, because that's where your first mark comes from. And if your working does not support the triangle, you can lose the first 2 marks straight off. This gives us 2.4. We then square root the 2.4, which gives you 1.5. I'm going to go to 1.55, keep it to 2 decimal places. So the depth of the oil, this is a tricky bit, right? So the depth of the oil, this green line that I'm drawing over this is your radius of 1.9, right? We've worked out that x is 1.55. So we want this wee bit here down the bottom, the depth of the oil. So the depth is your radius of 1.9, take away your answer of 1.55. So remember, the 3 scenarios are height of a tunnel is add to your radius, depth of liquid, take away from your radius, and if it wanted width of liquid is when you double. So this one is then just 1.9, take away 1.55 is 0.35 metres. Again, it would be okay to round that to 1.6 and say 0.4 metres. Okay, next question. We're talking about scale factor, mathematically similar shapes again. So this one's got algebra. This is not nice. This is a show that question. So what we have to do is pretend we were going to go find either the length of the small one or the length of the big one. So I'm going to go pretend that I was going to find this length here, right? I'm going to pretend that wasn't there just now, right? My scale factor, so I would have said, right, new equaled. It's just talking about length, so it's just scale factor times old, all right? So my new length is the bit I've put the square around. So my new length is x squared plus 5. My scale factor is big over small, or new over old, is 18 over 6 times, and the old length was 2x. So that's me kind of set up using a general formula. Then that gives me x squared plus 5 equals 18 over 6 is just 3. 3 times 2x is 6x. Now, does that not look really close to what they've got? They've literally just brought everything to one side. So that gives you minus 6x when you bring it over, all equal to 0. Now, the beauty of these questions is see that, show that for part A. Even though you can't do it, part B is simply start with their equation, factorise it and split it into 2. Sometimes it could be quadratic formula, but in this case it's not. So we're starting with x squared minus 6x plus 5 equals 0. So even if you couldn't do part A, you start with that and you break that into 2. Numbers that multiply to 5 and add to minus 6 are minus 1 and minus 5. Split them both up into 2b equations. That gives you x equals 1 and x equals 5. Now, most of the time, one of these is negative and you get to eliminate one. But then it tells us that xr is the shortest side of PQR, so we've defined the value of x. So I need to go back and look at that picture again. QR could either be 1 or 5 at the minute. So QR at the moment is 6, right? So x cannot be 1 because that would make PR shorter. QR has got to be the smallest side. So can you see that x equals 1 wouldn't work because that would make P to R 2. Whereas if I go with x equals 5, then P to R would be 10. So x equals 1 is no use. So I'm literally going to score that one out and say too small or too short. So x equals 5. And I think it was in centimetres. Yeah. So x equals 5 centimetres. So that was a wee twist on your normal one. And that's the end of the paper. Thanks very much.